So we will discuss a very important topic in physical chemistry, that is chemical equilibrium. So what is phase diagram? It is also called equilibrium or constitutional diagram. The plot of temperature versus pressure or temperature versus pressure against composition will give us the relative quantities of phases. What is phase? So phase is a homogeneous portion of a system with uniform physical and chemical characteristics in principle, separable from the rest of a system. So in phase, if there are a mixture of different phases, they can be separable from each other. So by saying phase, it can be solid, liquid, or the gaseous phase. So when we talk about water, it has got three phases: the gaseous phase, liquid phase, and the solid phase. Although basically water has got three phases, the composition is one, that is the chemical composition is H2O. So now a difference in either physical or chemical property. By when we say phase, can be a difference in the physical appearance, or there can be difference in the chemical properties. So gaseous state, seemingly only one phase occur, a mixture of many gases. Suppose in our atmosphere, in the environment, we have got many gases. So air is a mixture of oxygen, carbon dioxide, nitrogen, and many gases. So we cannot say that that it is consists of 2 phase, 3 phase, 4 phase. So because the air is a mixture of many gases, because the air is a mixture of many gases, we will say that it is a one phase. Now in case of the liquid state, often only one phase occurs. So the salt water solution is a liquid phase. It is only liquid. It is only, suppose sugar and water, it is a one phase. Although it is a liquid solution, it is a one phase. In solid state or solid phase, it can be in the crystalline phases, it can be in the polymorph phase, or it can be in solid solution. Now what is phase equilibrium? The phase equilibrium is always the one with the lowest free energy. So when the free energy is lowest, the reaction will be at equilibrium and the spontaneity will occur. What is equilibrium? So equilibrium state with minimum free energy under some specific combination of temperature, pressure, and combination. So the pressure and temperature combination has to be specific, otherwise the equilibrium will not be maintained. The driving force for a phase change is the minimization of free energy. So ultimately, when we make the phase diagram, our only reason is to minimize the free energy. Now, what is Gibbs phase rule? The scientist Gibbs has given us the Gibbs phase rule in case of the heterogeneous substances, that is P plus F is equal to C plus 2, where P is the number of phases present at equilibrium and C is the number of component, F is the number of degrees of freedom. The degrees of freedom can be any parameter like temperature, pressure, composition, etc. So now, the number of component in the minimum number of a chemically independent constituent need to be described by the composition. So like salt water composition is 2 because it is a combination of NaCl and water. In solid magnesium silicate, we can get composition as 2 because it is a combination of magnesium oxide and silicon dioxide. As well, in case of solid and magnesium aluminum silicate, the composition is 3 because it has 3 components, totally different 3 components like magnesium oxide, aluminum oxide, and silicon dioxide. So the degree of freedom is a number of independent variables that must be specified. So that can be pressure, temperature, pressure composition, the composition temperature, etc. Now one component system, the best example of the one component system is the water system. We know that water has got 3 phases. It is solid, liquid, and gaseous phase. So water exists in 3 phases. but the composition is 1. So the chemical composition is H2. The chemical composition is H2O. So as we can see at the point A is called the triple point. The point A is called the triple point because at this point A, all the three phases, like say the gas phase and the liquid phase, the solid phase, all will meet. So it is a triple point, and the degree of freedom here will be at the point 1. So when the phase is 1, F will be 2. When the phase is 2, F will be 1. And again when the phase is 3, F will be 0. So when the degrees of freedom become 2, we will say it as bivariant phase. When the degree of freedom is 1, we will say it as univariant phase. And when the degree of freedom is 0, we will say as the invariant phase. So when F is equal to 2 bivariant phase, then it is a field. That means the whole portion here in area CAB, the degree of freedom is 2. Suppose in the curve, say AB, AC, AD, the degree of freedom will be 1 and the degree of freedom will be 0 at a point. Along the curve, the degree of freedom will be 1 and along the area, the degree of freedom will be 2. The same we can see the same diagram. It is given here also. As you can see in this diagram, the three phases can coexist. So there is water, liquid and ice. It is a temperature pressure curve. So at the point A is called the triple point where all the three phases will coexist. And basically we know that at this normal temperature and pressure, all the three phases cannot coexist, but 0.0098 degrees centigrade is the only temperature where the water vapor and liquid will coexist, and also at a pressure of 1 atmospheric temperature. So basically the AD line is called the AD line is called the solid. The AD line is called the vaporization curve. Ice to liquid, it is called the fusion curve, and ice to water is called the sublimation curve. As you can see here also, this is the ice to liquid. This is called the melting curve. From vapor to liquid, it is called the vaporization curve, and from ice to water vapor, we will call it as the sublimation curve. One component can be seen in case of the carbon also. As you can see, carbon exists in many allotropic form. So there are many phases, but the composition is only one. So these are many allotropes of carbon. These are carbon nanotubes, the fullerene structure. Then we have got diamond, graphene. All these are the different allotropes of carbon. So it has got different phases, but the composition is one, that is carbon. So this is the phase diagram of carbon system. Phase diagram of carbon system. The degree, we need temperature and pressure to specify the system. As we can see, there are different phases. We can find liquid carbon also. We can find CVD, metastable state diamond. Then there are synthesis, diamond, shock wave. These are the different allotropic form of the carbon. More than 100 tons of synthetic diamond are produced annually worldwide by firms like Diamond Innovation. So these are the different allotropes of carbon. It is the phase diagram for the silicon dioxide. Ice, there are 18 different crystalline phases of the ice. This is the phase diagram for the 18 different crystalline phases of the ice. Pressure, temperature curve. This is the structure of the ice. Other example, so carbon. In case of carbon also we can see carbon can exist in solid form, liquid form and gaseous form. So there can be different phases Other examples are sulfur. Sulfur is also a one component system. Sulfur has got three allotropic forms. The three allotropic forms are rhombic sulfur, monoclinic sulfur, liquid sulfur, and gaseous sulfur. Out of the four sulfur, monoclinic and rhombic sulfur are solid, and the third type is a liquid sulfur, and the fourth type is a gaseous sulfur. So basically, this is a pressure temperature plot against the different allotropic form of the sulfur. Now the two component system in case of the binary system. This is a two component system. In two component system we can use eutectic system.